Welcome back. Uh, I think you listened all the sessions morning to evening in the last class, yesterday's class. So online, uh, actually, we got an idea about B3, creation and insertion and deletion. Yes, sir. So directly go for the B3 or you want to start with B3 insertion and deletion at least up to half an hour? You want B3? Yes, sir. Okay. I'll give the creation and deletion of B3 within 2 minutes. Then I'll go for the heat. Okay. Heat, that is mean heat, max heat available. So I'll go for max clear picture about insertion and deletion. The reverse further that is mean heat. That's it. Okay. And then I'll go for the introduction about graph traversal in this class, about graph and plot. Then if possible, go for VFS at the end. Otherwise, in the last session, I'll go for the graph traversal along with given and answer also. Okay. Then see here. I think in the last sessions, I already discussed about the number of rows in binary search tree and daily entry. Yes, correct? Binary search tree, binary means at least one node contains at most two children. At most means maximum two children, minimum zero children are also possible. The root node contains single node having zero children also called binary tree. Okay? And one more property available in binary search tree. One more property available in binary search tree, BST. That is, every node, every root node contains two types of subtrees. What are those? Left subtree and right subtree. So each and every left subtree values are less than compared with root node, and all the right subtree values are greater than compared with root node. So already given the instruction about PST and deletion about PST, and already completed about AVL concept. So AVL stands for generalization, generalized version of your binary search tree, that is AVL3, updated version of your binary search tree, that is AVL3. We are calculating balance factor in that. We are calculating balance factor in that. So balance factor equal to what is the formula? So height of the left subtree minus height of the right subtree available in between minus 1 to 1 means minus 1, 0 and 1, three values. Other than these three values, if you get minus 2 or plus to stop there and apply the rotations. How many rotations are already given? Four rotations. LL rotation, left rotation, right hand rotation, LR rotation and RL rotation. Left, RL. I think very easy. Within one step, you are pulling the middle element. LL means one rotation to the right side, one rotation to the left side, that is in RR. And in LR and RL, we have two rotations. But I will give the shortcut for that. Okay? I will give the shortcut for LR and RL. So try to find out the in-order elements. Okay? Try to sort out the three elements in which order? In order. Okay? Try to sort these three elements in order and find out the middle element in that. Middle element belongs to the root node. So we are having left side and right side. LR and RL. So same concept. Try to find out the three elements in which order? In order. In order means start from smallest element to the biggest element. These three elements in which order? Ascending order. Okay. And finally, after calculating these three elements in which order? In order. Finally, we need to pull the middle element that belongs to the root node. That is a shortcut for LR and RL. Okay. And deletion also available. And what is the difference in between AVL3 and B3? I will give. Okay. We are having two types. We are having two very important keywords available in B3. Very important here. B3 also called one more advanced updated version of your binary search tree. Okay, generalized version of binary search tree, that is B3. Okay, and now what are the very important keywords we are having in B3? I will give. Then I will go for the insertion and deletion. Then I will go for B3. Okay. B3 insertion and deletion plays a very important role. You are calculating just balance factor. You are having in deletion. We are having three cases in binary search tree. What are the three cases? If a node contains, when you are deleting a node in binary search tree, just verify that node contains zero children. Children is equal to least node. So directly delete. No problem. Okay. And the second case, if a node contains only one children, so move that children to the upper case and finally delete that particular node. So I'll give one that. Three cases. 11 and next here 10, here 12. Okay. Now this is the value one is correct. 10 compared with 11, less than 12 compared with 11, greater than. Now I want to delete 12 in binary search tree. So how many children for 12? How many children for 12? Zero children, na? Zero children. Very easy to delete directly. Very easy to delete. Very easy to delete. If you are having case 1 belongs to, it don't contain how many children? Zero children. Okay? But in ABL tree, try to calculate the balance factor for all the nodes in left side tree and right side tree. If you are identifying minus 2 or plus 2 in any node, stop there and try to apply any rotation from all the four. Okay? But just see here three cases. So this is one case. Now I want to delete 12. I want to delete 12 once again. Now this 12 contains how many children? One children. Now this is not the previous case. Now this is not the previous case. So I want to delete 12 means move this 30 to this place. Move this 30 to this place. Then in the next level we need to replace this with 13. Yes, correct, huh? So very easy. But we need to find out the balance factor. PSC lo balance factor find out zero, but ANC lo balance factor find out zero. This is case 2. A node contains how many children? Zero children. Very easy. Try to do it directly. A node contains one children. So move that children to the upper one and remove the parent node. Okay, remove the parent node in that. Remove the parent node means you are deleting 12. Now one more. I want to delete 11. I want to delete 11. 11 contains how many children? So two children. At that time, we are having two cases. In order predecessor and in order successor. So apply any one concept. Just don't apply two concepts at a time. Okay, that is not possible actually. So if you are applying in order predecessor means so compulsory that root node contains left side tree and right side tree. So if you are applying in order predecessor, if you are applying, okay, if you want to delete an element, okay, if you want to delete an element, that node contains two children. So apply any one of the two cases. What are those two cases? Either in order predecessor or in order successor. Okay, in order predecessor. So we are verifying. Okay, we are identifying the left subtree max element. Okay, left subtree element find out element max element. If you are applying in order successor means we need to go for right side tree, find out the mean element in right side tree. That is equal to the root. Now the is remove it. Okay, max element and you are applying in order predecessor. So if you are picking mean element from right side tree means you are applying which concept? In order successor. I think anyone? So if you are applying in order predecessor or in order successor, compulsory after applying. So just verify the balance factor. When you are applying balance factor, in which tree we are applying balance factor BST or ABL tree? Balance factor only flowing in ABL tree. A stands for two inventors are invented ABL tree na? Adelson, Valsky and Landis. ABL stands for business score. Okay? Two inventors. So first inventor only two letters తీసుకున్నాము. Landis నుండి ఒక letter తీసుకున్నాము. Adelson, Valsky. The name here, certain name ఉంది తీసుకున్నాం. Two keywords ఉంటాయి. So second inventor నుండి ఒక L తీసుకున్నాం. So two inventors are invented the updated version of PST, that is ABL3. So ABL3 లో ఒకటే ఒకటి ఉంటుందమ్మా balance factor. So balance factor don't exceed -1 or 1. -2 or +2 వచ్చిందంటే compulsory stop here and apply the rotation. LL or RR or LR or RR rotation I have already given clearly. Then I go for B3. Okay. So B3 having one or two very important keys, that is order. Already given in the last class. You will observe on the screen. B3 insertion deletion available on the screen? Yes, I will give one for one problem. Okay, very easy to understand. Then I'll go for heat. Then I'll go for draft traverser. That's the end of your ADS. So after draft traverser, BFS and DFS, we are having divided conquer. The divided conquer from which concept? That is not from ADS. That is from algorithm analysis. In your subject, you have two subjects. In your subject, how many topics? Two topics. First one, first subject, ADS. Second subject, algorithm analysis. That is concept to ready to add this. Compared to the ADS place, that concept are combined together into your concept. 1.5 minute belongs to ADS. Second, other concept belongs to algorithm analysis. That is also called design and analysis of algorithm. That is concept in the middle. Okay, now. So design and belongs to the most very important concept from algorithm analysis. Okay, so all those are the concepts are available in the next level of draft traverser. I'll go for B3. Within few minutes, I'll go for B3. B3 contains a very important one, order. Construct a B3 using the order with the help of list of elements. Okay, remember here, construct a B3 using which one? Order. Order means what and what's the meaning for key? Okay, one more keyword available here, one more keyword available here, one more keyword. First one, order. Second one, key. Order belongs to M, and the compulsory in your hand order available. Compulsory question like instead of order is started. Income going calculate key value belongs to M minus 1. Key value belongs to M minus 1. Always remember these two very important keywords in B3. B3 belongs to the generalized updated version of your binary search tree. We are calculating two very important concepts in this. Okay, we are calculating very important two concepts, order and key value. So what is the need of this order? What is the need of this key value? I will do. Okay, with the help of this. I think I already given in the last class the very important creation of your B3. Try to write. I think we already listen the class in the last session. But once again I will give before deletion. Okay? Before deletion I will do this one. You want insertion and deletion from B3, then I will go for EP. Okay? If you didn't understand the deletion and the creation, actually in BST, ADS3, B3 belongs to the big complex. B3 is very easy. B3 very easy to understand. Okay? But very complex for this one? B3. Okay, B3 compulsory. After this program, just don't miss the class and just listen carefully up to the last minute in creation and deletion. Okay? Just see it. Right here, one very important question. I will do the small one. Construct B3. Construct B3. Construct a B3. Construct a B3 of order 3. Construct a B3 of order 3. Construct a which tree? BSTR, AVN tree, B3. B3. Construct a B3 of order 3. Order 3. Order is the compulsory third amount. Okay? Order 3. Rules are going compulsory. And the rules are going to time is okay. So, I'm going to direct creation. Listen carefully. Order 3. For the given list of elements. For the given list of elements from 1 to 10. Construct a B3 of order 3 for the given list of elements from 1 to 10. Construct a which tree? B3 for the given list of elements. Construct a B3 of order 3 for the given list of elements from 1 to 10. Construct which tree? B3 of order 3. And tell me the list of elements. 1 to 10. Always just remember here, in B3 the elements are available in which order? Sorted order. Always the elements are available in B3 which order? Sorted order. Compulsory remember. Always the elements are available. Duplicates are not allowed in B3. Duplicates are not allowed in AL3, B3, BST. Duplicates means same node once again available in BST? No. Same node available in AL3? No. same duplicate element available in B3? No. But available in next one. Which one I will give? Okay, the next one. Okay. Tell me the problem. First, tell me the problem. Tell me the problem. Make it fast within few minutes. I will do this one. So the given list of elements 1, 2, 3, and so on. Then, how many elements we can insert to construct a B tree from 1 to 10? Tell me the order. Tell me the order. Order m equal to 3. ఈ రెండు పక్కకు రాసుకోవాలి. Allow to write each and every step. Okay, we are giving in your notes. Each and every step compulsory. Next, we need to write calculate. It is below one calculate cheyali. I think everyone knows e equal to m minus 1. That is 3 minus 1 equals to 2. E equals to 2. So, the generalized version of a node contains here 2 keys. వాడు ఇవ్వగానే ఇలా చేసేసుకోవాలి. వాడు ఇచ్చిన ఏ ఎలిమెంట్స్ ఇంక్లూడ్ చేయాలో ఫస్ట్ రాసుకోవాలి, తర్వాత ఆర్డర్ రాసుకోవాలి. ఓకే, రైట్ an order for this, then find out the calculate find out or calculate which value, e value. E equal to what the formula, m minus 1. So order ఇచ్చాడు కదా, e value ఎంతమ్మా 3. How many elements we can insert in one single node? We can accept up to maximum k1 and k2. So the node looks like, the general format of the node looks like in your this B3, it can accept up to how many elements? 2 elements. 2 key values are available. 2 key values are available. K1 and K2. Order 5 and అనుకోండి. Order 5 and అనుకోండి. So at that time n equal to 5. E equal to 4. So how many keys are available in your node? K1, K2, K3, K4. It can accept up to 4 elements. It can accept up to 4 elements in your node. I think you got idea na? So how to calculate m and e value and the general format of your K1 and K2. Now just see here. First I want to insert 1. So what is your node? Node looks like this one. General formula of this node. Yes, correct? General formula of this node accept how many values? Only 2 key values. First I want to insert 1 in the first place. Okay? And you want to insert 2. Is space available in this? Space available? Yes, space available. But 2 compared to 1. Left side or right side? Right side. Why greater than? Always the elements available in which order? Sorted order. So 2 here. Okay? 2 here. Yes, correct? 2 here. Next tell me, I want to insert 1 and 2 completed. Then I go for 3. Space available in this? No space available. So write like this. Write like this. Write like this. Okay? After node just write like this. And if you exceed the maximum number of key values in the node, try to identify the middle element. Try to identify the middle element. What is the middle element? 2. Pull this middle element 1 level up. Pull this middle element 1 level. This is very important part. Okay, if you exceed the general syntax of the key value, K1 and K2, maximum can accept 2 values. Now third value వచ్చింది. Third value రాగానే ఏం చేయాలమ్మా? Identify which element? Middle element. And try to put star on this and find out this middle element. Then after identifying the middle element, so that middle element goes up to which level? 1 level up, not 1 level down. 1 level up. 1 level up. And this is 2. And 2 will enter and enter 2 will enter and enter 3. Okay? First 1 to handing, 3 handing, second is a hand. Make it fast. I will do the next B3. Next B3 after inserting 3. Make it fast. First put star on this. You are writing 3. Put star on the middle element. Okay, put star on the middle element. Put star on the middle element. And this middle element identify 2. That middle element goes up to 1 level up. 1 level up.
జలుబు చల్లగా ఉంది అనుకో.
అదే చూస్తున్నా అక్క, మార్చుతున్నా. ఇప్పుడు కొంచెం వాల్యూమ్ తగ్గించాక ఒకసారి ఇప్పుడు చూడవా.
So two available here, two available like this, and tell me two left side untadamma, two left, one, and two right, three. This is the next tree. This is the next tree. Make it fast. This is the next tree. Okay. This is the next tree. After completion of this, after inserting three elements, after inserting three, next we need to go for four. We need to go for four. Okay. We need to go for four. Where we need to insert four? Now tell me. First, always start from root node. And very important point now. So in root node, a space also available. In root node, a space also available. Two spaces or three spaces or four spaces are also available. Just don't insert a new element in root node in B3. Just don't insert a new element in root node in B3. Always insert a new node in the next level after root node. Now tell me what is your element? 4. So after 2, 4 available, 2 to right or left? Right. So, right. Right side now. Goes to right side. 3, 4, and 5. 3, 4, and 5. Exceeds the range of the node. Exceeds the range of the node. Now tell me here. Once again, middle element 4. What is the middle element? 4. And this middle element one level goes one level up. One level up ఉన్నప్పుడు పైన రూట్ నోడ్ స్పేస్ ఉందా అమ్మా? ఉంది కదా? స్పేస్ ఉంది కదా? So what is the next tree here? Tell me the next tree one is 4 side entering, 3 right side entering, 5. Now tell me here. 2 left side, 1. 2 right side, 3 and 3 only now. 4 already shifted to the root node. 4 already shifted to the root node. Now tell me 4 right name untadi 5. Yes, correct? Till now read out? No. Now tell me order 3 now. Order 3. It can accept up to how many children? 3 children. Okay? It can accept up to order 3 candidates. How many children? 3 children. Now 5 you are inserted now. 5 you are inserted. Then go for 6. Then go for 6. Then go for 6. Make it fast. Where? Start from 2. Start from 2. Space available or not available. Just don't insert a new node in root node. Always move to the next level. So compared with this, 6 available to the right side of 4. So right side of 4. So just you are in this place. So in 5 space available. In 5 space available to insert a new element. Yes. You are inserted 6. You are inserted a 6. You are inserted a 6. Now this is the new tree after inserting 6. Make it fast. Try to draw each and every tree. In every step, finally you will get all the marks. You will get full marks. When you are inserting one element in every step, compulsory draw each and every new tree, updated tree, finally you will get full marks for your tree. Okay? Make it fast. Make it fast. I don't know, tell me. 5, 6, 5, 6, 7. 5, 6, 7. Okay? 5, 6, 7. So which one middle element? 6. One level up. One level up. One level up. So here and here. So what is the next tree I want to draw this? Tell me what is the next tree? So here 6 moves to the up now. 6 moves to up. 6 available in this place. The space available in root node. Space not available in root node now. Space not available in root node. At that time you are identifying 4 belongs to the middle element and left and right. So what is the root node? Tell me the root node. 4 belongs to the root node and 4 to left hand amma 2, 4 to right hand means 6. You draw it in the box. Okay, 4 to right hand means 6. 2 to left hand amma 1, right hand means 3 and 4 to right 6 వచ్చేసింది. 6 to left hand means 5, 6 to right hand means 7. That's it. This is the new tree. This is the new tree. Okay, any doubt? Now, I want to insert 8. 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 Where we can insert 8? First, this one, comma available, comma available, comma available, comma, comma, comma. Comma means one more space available. Yes? Comma means what? One more space available. Okay? Here also comma, but see up to some time. Okay? Only one element. Now it can accept up to how many keys? 2 keys. And next, 8. Verify here. Where we can insert 8? Where we can insert 8? After 7. After this is the new tree. Next 9 ఇక్కడికి వస్తాయి కదమ్మా నెక్స్ట్ 1 level up అంతే కదా 1 level up. Now tell me the new one. 4 2 6 పక్కన కామా ఉంది కదమ్మా 6 here 8 6 కి లెఫ్ట్ హ్యాండ్ అమ్మా 5 6 కి రైట్ హ్యాండ్ 7 8 కి లెఫ్ట్ హ్యాండ్ 7 కదా 7 కదా 8 కి లెఫ్ట్ హ్యాండ్ 8 కి లెఫ్ట్ హ్యాండ్ ఓకే నెక్స్ట్ 8 కి రైట్ హ్యాండ్ 9. That's it. This one belongs to 6th right, 8th left. Yes, correct. 6th right, 8th left. Next 9. Next I want to insert. Then where we can insert? That's it. This is the last thing. That's it. This is the last. Yes, any doubt? Try to draw all the days. Try to draw all the days.
And here I'm giving the exercise problem. Try to solve this problem in your home. Okay, try to solve this problem in your home. Try to solve this problem in your home. Construct B tree. Construct B tree of order 5. Just don't solve here. Try to solve this problem in your home. Construct B tree of order 5. It can accept up to how many elements? 4 elements. Fifth element వచ్చినప్పుడు middle element identify చేయాలి. ఓకే, మిడిల్ ఎలిమెంట్ ఏమవుతుందమ్మా? థర్డ్ వన్ అవుతుంది. ఓకే, మిడిల్ ఎలిమెంట్ సెకండ్ వన్ ఇక్కడ, అక్కడ థర్డ్ వన్ అవుతుంది. Construct B tree of order 5 for the given list of elements. For the given list of elements from 2 to 40. From 2 to 40. All the even numbers. From 2 to 40. In bracket the condition. Select only the even numbers from 2 to 40. Okay. Select which numbers? In between, not 0. Select even numbers in between 2 to 40. Means what? 2. Second element 4. Next element 6, 8, 10, 12, 14, 16 and so on. Insert each and every element. Try to practice by yourself by own elements, by own problems, by own examples. Very easy to understand. Okay, very easy to understand. Now this one contains like this. This one contains like this. ఇక్కడ ఏంటిదమ్మా 5, ఇక్కడేంటి 7, ఇక్కడేంటి now only 2 elements I want to give. B tree deletion ఏంటమ్మా? So what is that B tree deletion? B tree deletion. So where we are having 3 ఎక్కడ ఉంది? అంతే కదా, అంతే కదా. Now tell me here, we are having 2 cases in deletion. We are having 2 cases in deletion. I will give those 2 cases. First case, if target key is a leaf node, if a target key, B tree deletion, B tree deletion, side heading here, B tree deletion, side heading here, B tree deletion. If a target key is a leaf node, 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 so leaf node and rasi ఇక్కడ టార్గెట్ కీ ఇస్ లీఫ్ నోడ్ కదమ్మా. టార్గెట్ కీ అంటే ఏ నోడ్ డిలీట్ చేస్తున్నారో దాన్నే టార్గెట్ కీ అంటారు. సెకండ్ కేస్, ఇఫ్ ఎ టార్గెట్ కీ ఈజ్ ఇంటర్నల్ నోడ్, ఇఫ్ ఎ టార్గెట్ కీ ఈజ్ ఇంటర్నల్ నోడ్, ఇంటర్నల్ నోడ్ అంటే ఇక్కడ మధ్యలో ఉంటుంది. ఓకే, నా ఐ వాంట్ ద 2 టైప్స్ ఆఫ్ నోడ్స్. లీఫ్ నోడ్ ఏంటి, ఇంటర్నల్ నోడ్ ఏంటి? ఇప్పుడు చెప్పండి అమ్మా. 2కు లెఫ్ట్ ఏంటి 1, 2కు రైట్ ఏంటి 3, అండ్ 6కు లెఫ్ట్ ఏంటి 5, అండ్ అంతేనా? దిస్ వన్ 7 and this one 9 and 10. All are in the same level, na? All are in the same level. Very important. That is in B tree. That is in B tree. Now I want to delete. I want to delete 9. I want to delete 9. I want to delete 9. Target key is what? One belongs to leaf node, 3 belongs to leaf node, 5 belongs to leaf node, 7, 9 and 10 belongs to leaf node. 4. Okay, parent node belongs to 4. Now, what is your target key? Which element you want to delete? 9 elements. Okay, 9. You want to delete 9. You want to delete which element? 9. Root node, parent node to the leaf node. 9. 4 compared with greater than. And 6 and 8. Compared with 6 and 8. 9 available to the greater than this node. And here 9 identified now. 9 identified. Any next level available for this? 9 belongs to which node? Leaf node. So directly delete. Directly delete. Directly delete. But before deleting, one very important concept. So leaf node దగ్గర 3 cases ఉంటాయమ్మా. Write those 3 cases. First one, or write those 2 cases are at least. That leaf node contains leaf node and Rasi. 2 cases rather than more than enough. This is not available in your syllabus. Leaf node. That leaf node contains more than minimum number of keys. That leaf node contains more than minimum number of keys. That leaf node contains more than minimum number of keys. In leaf node, once again, how many cases? 2 cases. That leaf node contains, tell me, that leaf node contains more than minimum number of keys. Second case, that leaf node contains minimum number of keys. More than minimum number of keys and minimum number of keys. More than minimum number of keys and minimum number of keys. You got an idea in deletion actually? All these are the cases I already understand. You already understand these cases. Can I skip this one? No, huh? You already know the B-tree deletion? Very important. So first ఏమున్నాయమ్మా 2 cases. First case ఏంటి? Your node belongs to which node? Leaf node. Leaf node లో మళ్ళీ 2 cases ఉన్నాయి. So that leaf node contained minimum number of keys. And how to identify minimum number of keys and maximum number of keys? Now just see here. I'll give this one. Can I rub this one? This one. Now order 5 B tree contain how many minimum childrens, how many minimum keys, how many maximum keys? I think everyone knows m equals to 5. What is the key value? 4. Means this is equals to maximum of number of keys, that is equals to 4. But how to identify minimum number of keys in your node? Actually, how the node looks like? How the node looks like for order 5? K1, K2, K3, K4. Yes, correct? K1, K2, K3, K4. So maximum number of keys. Minimum number of keys, how to calculate? Any formula? Tell me anyone now. M by 2. M by 2. M by 2. Plus 1, minus 1. M by 2 minus 1. M by 2 అంటే ఏంటన్నామా 5 by 2. 5 by 2 ఏం తీసుకోవాలి? ఫ్లోర్ తీసుకోవాలి. 2.5 కదా ఫ్లోర్ వాల్యూ. వాట్ ఇస్ దట్ ఫ్లోర్ వాల్యూ? 2. టెల్ మీ ఫ్లోర్ వాల్యూ సీల్ వాల్యూ. విచ్ వాల్యూ యూ వాంట్ టు సెలెక్ట్? 5 by 2 అంటే 2.5 వచ్చింది. యు ఆర్ సెలెక్టింగ్ సీల్ వాల్యూ ఆర్ 4 వాల్యూ ఫర్ దిస్. seal value. 2.5 seal, tell me. Seal function, floor function idea unda amma? అస్సలు తెలుదా? మరి బీటీ డిలీషన్ ఎట్లా తెలుస్తుంది మీకు? సీల్ ఫ్లోర్ తెలియకపోతే ఫస్ట్ we are targeting with the help of minimum number of keys in deletion. If you are not knowing floor and seal, that is not possible. So what is seal and floor? I will give within 2 minutes. Okay, just this is very important function available in your PPS. This is very important. Seal function and which function? Floor function. Seal అంటే ఏంటమ్మా? ఇదే seal. Floor అంటే ఏంటిది? అదే floor. సో 2.5 కి సీల్ ఫంక్షన్ ఏంటి, 2.5 కి ఫ్లోర్ ఫంక్షన్ ఏంటో చెప్తాను. ఓకే, సింపుల్, వెరీ ఈజీ టు అండర్స్టాండ్. టూ పాయింట్ ఫైవ్ ఫ్లోర్ అంటే ఆ రిమూవ్ తీసేసేయండి, పాయింట్ తర్వాత ఉన్న తీసేయండి. 2.5 ఫ్లోర్ వాల్యూ 2, 2.5 సీల్ వాల్యూ ప్లస్ వేసేసేయండి 3. 4.6 ఫ్లోర్, 4.6 ఫ్లోర్, 4.6 సీల్, 2.67 సీల్. సీల్ అంటే ప్లస్ వేసేసేయండి. ఇక్కడ దీన్ని మర్చిపోండిగా, దీన్ని మర్చిపోండి. సీల్ అంటే +1 వేయండి, ఫ్లోర్ అంటే ఇది వేసేసేయండి, డైరెక్ట్. ఓకే, ఎనీ డౌట్? నౌ 6.3 సీల్ 7, 6.3 ఫ్లోర్ 6.3 తీసేసేయండి, 0.4 తీసేయండి, 0.27 ఏదన్నా ఫ్లోర్ ఉంటే 6 ఉంటే 6, 3 ఉంటే 3, 4 ఉంటే 4, 5 ఉంటే 5. సీల్ అంటే +1 యాడ్ చేయండి అంతే. ఓకే, సీల్ అంటే +1, ఫ్లోర్ అంటే ఎక్స్ట్రా ఉన్నది తీసేసేయండి. ఓకే, ఎక్స్ట్రా ఉన్నది. ఎనీ డౌట్? నౌ m/2 5/2 సీల్, 2.5 సీల్, 2, 2.5 seal, 2 or 3? 3, 3 minus 1, 2. This is a formula for minimum number of keys. To calculate the minimum number of keys. To calculate the minimum number of keys, m/2 of seal, m/2 of seal, m/2 of seal. m/2 అంటే ఎంతమ్మా? 5/2 for order. 2.5 అంటే 2 or 3 and no confusion. ఓకే, 2.5 కి సీల్ అంటే +1 వేయండి 3, 2.5 కి ఫ్లోర్ అంటే 2 వేయండి. ఇప్పటి వరకు అయితే సీల్ ఫ్లోర్ ఐడియా వచ్చేసింది కదా. సీల్ ఫ్లోర్ మర్చిపోండి, ఒక సీల్ గుర్తుంచుకోండి. హౌ టు క్యాలిక్యులేట్ minimum number of children's, minimum number of keys in your node. That is a formula m/2 of seal -1. So m/2 of seal -1. Order 5 కి ఎంత అమ్మా? మినిమం కీస్ 2, 3 - 1 కదా. 2.5 ఆఫ్ సీల్ 3, 3 - 1 2. సో మినిమం చిల్డ్రన్ ఎన్ని ఉంటాయమ్మా? దానికి 2 ఉంటాయి. ఇప్పుడు చేయండి, ఆర్డర్ 3 కి మినిమం చిల్డ్రన్స్ ఎన్ని ఉంటాయి? ఆర్డర్ 3 కి మినిమం చిల్డ్రన్స్ ఎంత, మాక్సిమం చిల్డ్రన్స్ ఎంత? మినిమం చిల్డ్రన్స్ 3/2 ఎంత అమ్మా? 1.5, 1.5 seal, 2, 2 - 1. How many minimum number of children in every node? 1. How many maximum number? 2. That's it. I think everyone knows. Key value, that is m-1. Now you got the difference in between minimum number of children and maximum number of children. So order 5 ki minimum enta amma? 2 children. Maximum enta? 4 children. Okay, K1, K2, K3, K4. 5, order 5. Key equal to m-1. Yes, correct? Now how to calculate minimum number of children? How to calculate maximum number of keys in your node? Minimum number of keys m/2 of seal -1. Maximum means m-1. Maximum means order -1. Okay, K1, K2, that is the node, general syntax of a node in order 3. Order 7 లో maximum node 6 కదా. ఆర్డర్ 7 లో ఎన్ని కీస్ ఉంటాయి? K1, K2, K3, 6. మినిమం ఎన్ని ఉంటాయి? ఆర్డర్ 7, 7/2 ఎంత అమ్మా? 4, 4 - 1 3. Minimum any children? Minimum any keys? 3 keys. How to calculate minimum and maximum? Very easy, na? Maximum means m minus 1. Minimum means m by 2 minus 1 of seal. Now for this problem, what is the minimum number of keys? 1. Maximum number of keys? 2. Now, before deleting, that is the first case in leaf node. What's that first case? That leaf node contains more than minimum number of keys. Minimum number 1. ఇక్కడ more than 1 minimum number of keys ఉన్నాయి కదా, more than minimum number of keys ఉన్నాయి. ఆర్డర్ 5 లో మినిమం నెంబర్ ఆఫ్ కీస్ ఎంత అమ్మా? 2. మ్యాక్సిమం నెంబర్ ఆఫ్ కీస్ ఎన్ని? 4. 2 ఉంటే మినిమం నంబర్, 3 ఉంటే మోర్ దాన్ మినిమం నంబర్, 4 ఉంటే మోర్ దాన్ మినిమం నంబర్, 2 ఉంటే మినిమం నంబర్ ఆఫ్ కీస్. 2 ఉంటే టచ్ చేయొద్దు. ఇక్కడ ఏమి ఉంటే టచ్ చేయొద్దు? 1 ఉంటే టచ్ చేయొద్దు. ఇక్కడ ఎన్ని ఉన్నాయమ్మా 10 లో? మోర్ దాన్ minimum number of keys. How many minimum number of keys in every node? 1 in order 3. Maximum number of keys 2. Now here we are having 2 children. So finally very easy to delete 9. Very easy to delete 9. Directly delete. Okay, directly delete. If a node contain a leaf node contains how many cases? More than minimum number of keys, same minimum number of keys. Okay, more than ఉంది కదా, more than ఉంటే ప్రాబ్లం లేదు, more than ఉంటే డైరెక్ట్ డిలీట్ చేయండి. మినిమం నంబర్ ఉన్నప్పుడు ప్రాబ్లం. ఓకే, మినిమం నంబర్ ఉన్నప్పుడు ప్రాబ్లం. నా ఐ వాంట్ టు డిలీట్ 5. I want to delete 5. I want to delete 5. Or then I want to delete 7. I want to delete 7. I want to delete 7. So verify where 7 available? Yes. So leaf node, that is leaf node or internal node? Leaf node. This leaf node contains minimum number of keys or more than minimum number of keys? Minimum number of keys. Minimum number of keys ఉన్నప్పుడు very important amma. Minimum number of keys ఉన్నప్పుడు చాలా important. So what is that minimum number of keys? I will give. Just write. Once again 3 cases. We are having 3 cases in this. We are having 3 cases in this. This is end amma, greater than minimum number of keys. ఇంతకుముందు డైరెక్ట్ డిలీట్ చేస్తారు ఎందుకంటే మోర్ దాన్ మినిమం నెంబర్ ఆఫ్ కీస్ ఉంది. ఓకే, your node belongs to either leaf node or internal node. Leaf node లో మళ్ళీ ఏమేమి ఉన్నాయి? 2 cases ఉన్నాయి. If the node contains greater than minimum number of case like 9 and 10. If the node contains equal to minimum number of case, equal to minimum number of case ఉన్నప్పుడు how many cases? 3 cases. Write those 3 cases, then I'll give small break. Just don't go to outside. Case 1 here. Borrow from immediate node. Borrow from ఒక కప్ పెట్టేసాను, కప్ పెట్టేసాను అంతే. నేను తాగేస్తా, లేకపోతే కప్ పెట్టేసానండి. ఒక సెకండ్ కప్ పెట్టే. Borrow from immediate left node sibling. Borrow from immediate left node sibling. Second case, borrow from immediate right node sibling. If a node contain how many keys? Minimum number of keys ఉన్నప్పుడు ఈ 3 cases. First case ఏంటి? Borrow from left node sibling, borrow from right node sibling, borrow from right node sibling. Third case, merging. Third case, merging. Merging and rana ante. Merging. Now I want to delete 7. I want to delete 7. I want to delete 7. 7 contain 7 available in your tree? 7 available in your tree? Yes, 7 available in your tree? Yes, 7 available in your tree. Yes. This contain minimum number of keys, sir. More than minimum number of keys? Minimum number of keys. Minimum number of keys number 3 cases. దీనికి లెఫ్ట్ సిబ్లింగ్ ఉందా అమ్మా? లెఫ్ట్ సిబ్లింగ్ ఉంది. రైట్ సిబ్లింగ్ ఉందా? రైట్ సిబ్లింగ్ కూడా ఉంది 7 కు. 5 కి లెఫ్ట్ సిబ్లింగ్ ఉందా? లేదు. 5 కి ఇమీడియట్ లెఫ్ట్ సిబ్లింగ్ ఉందా? లేదు. 5 కి ఏముంది? ఇమీడియట్ రైట్ సిబ్లింగ్ ఉంది. అండ్ 7 కు లెఫ్ట్ సిబ్లింగ్ ఉంది, రైట్ సిబ్లింగ్ ఉంది. So this is called for 7, 5 called left sibling, immediate left sibling. For 7, 10 belongs to immediate right sibling. Okay. And now 5 kenti, this is immediate right sibling. 10 kenti, 7 belongs to immediate right sibling. 10 ku left sibling unda? Yes. Right sibling unda? Ledu. 5 ki left sibling unda? Ledu. Right sibling unda? Undi. Now any doubts? Once again, I will repeat. This is not sibling. Sibling ante ivvamma. 3 ki siblings unnaya amma? 3 ki siblings unnaya? Yes, left sibling undi. Right sibling unda? Ledu. Immediate ledu. 7 ki left sibling undi, right sibling undi. 10 ki left sibling undi, right sibling ledu. 5 ki right sibling undi, left sibling ledu. Okay? You got an idea? Any doubt? Now I'll go for only 2 cases, then I'll close. Okay. How to delete? Where we are deleting 7, first delete 5. First delete 5. How? Delete 5, not 7. Borrow from immediate. రెండు లైన్ కొట్టి ఏదైనా ఒకటి తీసుకోండి. 7 delete చేసేటప్పుడు రెండు లైన్ ఏదైనా ఒక దగ్గర అప్లై చేసుకోండి. రెండు దగ్గర అప్లై చేసుకుంటే ఎక్కువ పెట్టండి. Don't take more than one borrow. I'll give that case. Delete 5. Delete 5. How to delete 5? Five contents. Now 5 contents, left sibling or right sibling? Right sibling, no left sibling. 7 content left sibling and right sibling. 10 content left sibling but no right sibling. Now I want to delete which node? 5. So 5 content right sibling and borrow from right sibling. Borrow from right sibling ante borrow from right sibling. Ela borrow cheyali cheppandi? Before deleting 5, before deleting 5, borrow from right sibling. Borrow from right sibling. Borrow అంటే ఇదేం పోతుంది, ఇది పైకి వెళ్తుంది, ఇదేమొస్తుంది కిందికి వచ్చేస్తుంది. ఓకే, రైట్ సిబ్లింగ్ నుండి ఒకటి పైకి వెళ్తుంది అమ్మా, పైకి వెళ్తుంది, ఇంకోటి ఏమొస్తుంది 6 కిందికి వచ్చేస్తుంది. నెక్స్ట్ ట్రీ ఏంటది? 4, 4 కు లెఫ్ట్ సైడ్ ఏంటి 2, 2 కు లెఫ్ట్ ఏంటి 1, ఇదేంటి 3 అండ్ 4 కు రైట్, 4 కు రైట్ ఏంటిది 7, 7 ఇక్కడ ఉంటుందా 8 రైట్ సైడ్ ఉంటుందా 7 అవైలబుల్ 8 టు ద లెఫ్ట్ ఆర్ 8 టు ద రైట్ 7 పైకి వెళ్తుంది కదా 7 ఏ ప్లేస్ లో పెట్టాలమ్మా 6 ప్లేస్ లో పెట్టాలి. I want to delete 1. I want to delete 1. I want to delete 1. In where 1 available? Yes, complete left side. Okay. In that node, how many number of keys? More than minimum number of keys or minimum number of keys? Minimum number of keys. Before deleting minimum number of keys, borrow from left subtree, sorry, left, borrow from immediate sibling or immediate right sibling. But 1 కు left sibling ఉందా 1 కు right sibling ఉందా 1 కు left sibling ఉందా లేదు 1 కి ఏం sibling ఉంది right sibling. Tell me 3 available here, 3 available here, just you are removing this one and 2 available. That's it. That's it na 2 కిందకి వచ్చేస్తుంది 3 పైకి పోతుంది 1 రిమూవ్ అవుతుంది. Now I want to delete 2. I want to delete 2. I want to delete 2. 2 contain left sibling, 2 contain right sibling. How to delete? Case 3. Merging. How to merge? Yes. How to merge? This one. This one. Merge these two. Merge these two. But no sibling na. Same you will get. You are deleting. But 2 belongs to leaf node na. 2 belongs to leaf node. Directly, you know you want to delete. Why? Because only one key available in this. But before deleting, compulsory we need to verify immediate left sibling, immediate right sibling. పైకి వెళ్ళి మెర్జ్ చేయాలి. పైకి వెళ్ళి మెర్జ్ చేసి ఎక్స్ట్రా ఉంటే అప్పుడు ఎక్స్ట్రా ఎప్పుడు ఉంటుంది అంటే ఆర్డర్ 5 లో ఎక్స్ట్రా ఉంటాయి ఎలిమెంట్స్. దీంట్లో ఒకటే ఉంది కాబట్టి కన్ఫ్యూజన్ ఉంది. ఓకే, ఆర్డర్ 5 లో ఎక్స్ట్రా ఉంటాయి ఎలిమెంట్స్, అప్పుడు అన్ని మెర్జ్ చేసేయాలి. ఓకే, మెర్జ్ చేసి అప్ టు 4 వరకు మెర్జ్ చేయొచ్చు. ఎస్ కరెక్ట్, అప్ టు 4 వరకు మెర్జ్ చేయొచ్చు. ఇక్కడ 1 ఉంది కదా, పైకి పంపించేసారు, 2 డిలీట్ చేసేసారు అంతే. మెర్జింగ్ యువర్ అప్లైడ్ మెర్జ్, బట్ యువర్ ఐడెంటిఫైడ్ ఓన్లీ 1 key. That's the reason just you are deleting 2 directly and you are merging with 3 and finally you are deleting. That's it. Okay, I think combination of all the nodes you are merging if you are not having left sibling and right sibling. I want to delete 4. 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 Delete 4. How to delete? Before deleting, verify more than minimum number of keys or minimum number of keys. More than అంటే రెండు మొత్తం ఫిల్ అయితే మోర్ దాన్ అమ్మా. సో K1, K2, K3, K4. This is equal to maximum keys of order 5. ఈ రెండు కన్ఫ్యూజ్ కావద్దు, మాక్సిమం కు మినిమం కు. మినిమం ఎంత అమ్మా? m/2 of seal minus 1. 5/2 of seal, that is equal to 3 minus 1, that is equals to 2. అంటే minimum number of keys, that is equals to k1, k2 and 2 spaces. Okay, this is equal to k1, k2, k3, maximum keys of order 5, minimum keys k1, k2. k3 ఉంటే more than number of minimum keys. k1, k2 ఉంటే minimum number of keys. k1, k2, k3 ఉంటే more than minimum number of keys. more than minimum number of keys ఉన్నప్పుడు డైరెక్ట్గా డిలీట్ చేసేసేయండి. బట్ మినిమం నెంబర్ ఆఫ్ కీస్ ఉన్నప్పుడు ఈ 3 కేసెస్ అప్లై చేయండి. లెఫ్ట్ సిబ్లింగ్, రైట్ సిబ్లింగ్, రెండు లేకపోతే మెర్జ్ చేసేసేయండి. ఓకే, యు గాట్ ఎ పాయింట్? దిస్ ఈస్ వెరీ ఇంపార్టెంట్. ఓకే, దిస్ ఈస్ వెరీ ఇంపార్టెంట్ వన్. నౌ ఐ థింక్ ఫర్ ఆర్డర్ 7, నౌ టెల్ మీ ఫర్ ఆర్డర్ 7, ఫర్ ఆర్డర్ 7, m ఈక్వల్ టు 7, కీ ఈక్వల్ టు 6, మళ్ళీ 7 అంటారు ఎవరు? కీ ఈక్వల్ టు m-1 కదా, కీ ఈక్వల్ టు ఆర్డర్ అంటే m ఈక్వల్ టు 7, కీ ఈక్వల్ టు 6. అంటే నోట్ ఎట్లుంటుందమ్మా ఆర్డర్ 7కు? నోట్ ఎట్లుంటుందమ్మా ఆర్డర్ 7కు? k1, k2, k3, k4, k5 and k6 for order 7. Okay, try to construct a B tree in your home. Try to construct a B tree from 1 to 25 of order 7. Try to construct a B tree of order 7 from 1 to 25. Try to construct a B tree of order 7 from 1 to 25. Okay, అంటే 1 2 3 4 5 6 డైరెక్ట్ ఇన్సర్ట్ అయిపోతుంది. 7 వచ్చినప్పుడు ఏం చేయాలమ్మా? మిడిల్ ఎలిమెంట్ ఫైండ్ అవుట్ చేసి మిడిల్ ఎలిమెంట్ పుల్ చేయాలి. 1 లెవెల్ అప్ అండ్ లెఫ్ట్ సైడ్, రైట్ సైడ్ డివైడ్ చేయాలి. ఓకే, సేమ్ ఆర్డర్ 7 అయినా, ఆర్డర్ 5 అయినా, ఆర్డర్ 9 అయినా. ఓకే, అదే ఈవెన్ నెంబర్ వచ్చింది అనుకోండి, ఆర్డర్ 4, ఆర్డర్ 6 అలా ఉంది అనుకోండి, అప్పుడు కీస్ ఎన్ని ఉంటాయి? 4 వస్తాయి ఎక్స్ట్రా కలిపి. అప్పుడు ఏం చేయాలంటే 2 + 1 3 చేయాలి, సీల్ చేయాలి. ఓకే, ఇప్పుడు మిడిల్ ఎలిమెంట్ ఈజీగా ఐడెంటిఫై చేస్తున్నారు. బట్ అప్పుడు ఈవెన్ నెంబర్ వచ్చినప్పుడు హౌ టు ఐడెంటిఫై మిడిల్ ఎలిమెంట్? సీల్ +1. ఓకే, 2 + 1 3. ఫర్గెట్ అబౌట్ దట్. 4 లో మిడిల్ ఎలిమెంట్ ఏంటి? 3. 4 లో మిడిల్ ఎలిమెంట్ ఏంటి? 3. 5 లో మిడిల్ ఎలిమెంట్ ఏంటి? 3. 6 లో మిడిల్ ఎలిమెంట్ ఏంటి? 6 లో 4. 7 లో మిడిల్ ఎలిమెంట్ ఇటు 3, ఇటు 3, ఇటు 3, ఇటు 3, ఇటు 3, ఇటు 3 పోతే ఏముండే అమ్మా? మిడిల్ ఎలిమెంట్ 4 నా? వెరీ ఈజీ టు ఐడెంటిఫై. మిడిల్ ఎలిమెంట్ పుల్ చేయాలి, పైకి పంపే, లెఫ్ట్ చేయాలి, రైట్ సైడ్ చేయాలి. ఓకే, ఆర్డర్ 5, ఆర్డర్ 7. నౌ యు ఆర్ క్యాలిక్యులేటింగ్ ద బీ ట్రీ ఫర్ కన్స్ట్రక్టింగ్ ఏ బీ ట్రీ ఫర్ విచ్ వన్? Constructing a B tree for of order 7. How the order 7 looks like? How many keys? K1, K2, K3, K4, K5, K6. Maximum number of keys in your node of order 7, that is 6. Minimum, tell me. m/2 of seal minus 1. 7/2. 3.5 seal. 4 minus 1. 3. మినిమం కీస్ ఎన్ని ఉండాలి? 3. k1, k2, k3 డిలీట్ చేసేటప్పుడు మినిమం k3 ఉందనుకోండి, కంపల్సరీ లెఫ్ట్ సిబ్లింగ్, రైట్ సిబ్లింగ్ అప్లై చేయాలి. k4, k5 ఉంటే మోర్ దాన్ మినిమం నెంబర్ ఆఫ్ కీస్. k6 అంటే మ్యాక్సిమం నెంబర్ ఆఫ్ కీస్. మినిమం అంటే 3, 4 అంటే మోర్ దాన్ మినిమం నెంబర్, 5 అయినా మోర్ దాన్ మినిమం నెంబర్, 6 అంటే మ్యాక్సిమం నెంబర్ ఆఫ్ కీస్. మ్యాక్సిమం నెంబర్ ఆఫ్ కీస్ ఉన్నప్పుడు ఈజీగా డిలీట్ చేయొచ్చు. మ్యాక్సిమం నెంబర్ ఆఫ్ కీస్ ఉన్నప్పుడు డైరెక్ట్ డిలీట్ చేసేయండి. బట్ మినిమం నెంబర్ ఆఫ్ కీస్ ఉన్నప్పుడు కంపల్సరీ యూ నీడ్ టు అప్లై 3 కేసెస్. Identify left sibling or right sibling, no left sibling, no right sibling, merge, apply merging. Now, any doubts? Yes? Next, right? The last one, last tree, heap tree. Heap tree. Any doubt in BST? No. BST updated version AVL tree. AVL tree లో ఒక కొత్త కాన్సెప్ట్ తీసుకొచ్చారు ఇద్దరు ఇన్వెంటర్స్. ఏంటది? బ్యాలెన్స్ ఫ్యాక్టర్. బ్యాలెన్స్ ఫ్యాక్టర్ షుడ్ బి ఇన్ బిట్వీన్ -1, 0, and if you exceed this value, either -2 or +2, stop there and apply any rotation from 4. LL, RR, LR or RL. Already applied, already given. Okay. Any doubts? Next. In B3, once again, two very important keywords: order and key value. Order and key value. Okay. Same. This is a generalized version of your binary search tree only, but we are using two very important keyword in B3, that is order and key value. How to calculate order? Compulsory available in your question. Order. How to calculate key? That is equal to m-1. How to find out the general syntax of your node? That is equal to key value. Key equal to some 7 minus 1, 6. So K1, K2, K3, K4, K5, K6. That is equal to maximum number of children, maximum number of keys. Minimum number of keys compulsory 3. That is m by 2 minus 1. M by 2 of seal 3 minus 1. Sorry, 7 by 2. 7 by 2 and 3.5. Seal of 3.5. 4. 4 minus 1. 3. Minimum number of keys in order 7. 3. Maximum number of keys 6. Okay, any doubt? So how to calculate minimum number of keys for the given order? M by 2 of seal minus 1. Maximum means m minus 1. Maximum means m minus 1. Any doubt? No. Now just write heap tree. Heap tree. What is heap? Write the definition, all of you. What is heap? Heap tree completed. Can I skip directly heap tree to divided conquer? Heap tree is very important. Heap tree. Heap tree is also called, tell me. Heap tree also called? Yes. Heap tree also called complete binary tree. CBT antaru. Right bracket lo. CBT. What is heap? Heap is a tree. Heap and a tree. What is heap? Heap is a tree based data structure. Heap is a tree based data structure. Heap is a tree based data structure. The heap tree is a complete binary tree. 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 What is complete binary tree? I don't know. So all the levels are available up to left side. But in this, we have two types of heaps. What are those two types of heaps? Mini heap and max heap. Huh? Anybody knows about mini heap and max heap? Just stand in your place and give the answer for this. Anybody? What is max heap? You already completed, na? Completed. Can I start this mini heap and max heap or directly jump to creation? Mini max heap explain cheyala direct ga creation ki vellipovala. First you need to explain, very important. Okay, I need to know the difference in between mini heap and max heap. Okay, complete binary tree, generalized version of binary search tree, that is B tree. Updated version of binary search tree, that is AVL tree. Generalized version of binary search tree, that is B tree. Complete binary tree, that is heap tree. How many trees totally in your syllabus? AVL tree, B tree, heap tree. AVL tree, B tree and heap tree. All of you right? Complete binary tree side heading. Complete binary tree side heading. CBT, complete binary tree side heading. All the levels of a tree are complete. All the levels of a tree are completely filled. All the levels of a tree are completely filled except the last level. all the levels of a tree are completely filled except the last level. Complete binary tree, just write in this one very important point. All the levels of a tree are completely filled except the last level. And in the last level, all of you write this very important point about CBT. All the levels of a tree are completely filled except the last level. And in the last level, all the keys are aligned. In the last level, all the keys are aligned as left as possible. Once again, I will repeat the very important point about CBT, complete binary tree. CBT short form, Randy, complete binary tree. Once again, here I'm repeating the very important statement about the definition of complete binary tree. Right in this, all the levels of a tree are completely filled except the last level. And in the last level, all the keys are aligned. Aligned and arranged on it. Okay. All the keys are aligned as left as possible. All the levels of a tree are completely filled except the last level, and in the last level all the keys are aligned as left as possible. As left as possible. Up to 1 o'clock, amma. 12. 1:30 an hour lunch. Up to 12. When I stop, Devyani na? Yes. 1 hour ago, చూడండి దేవ్యాని చెప్తుంది. I think up to 1 hour to the 12:30. I don't know. Devyani, just confirm. Confirm within 5 minutes, okay? When I stop, just confirm with your faculty member. 12:30 or 1 or 12. Now, once again, I will repeat the statement. All the levels of a tree are completely filled except the last level. And the last level, all the keys are aligned as left as possible. And write the max heap side heading. Max heap side heading. Heap tree divided into two types. Max heap and second min heap. Heap tree divided into two types. Heap tree divided into two types. Max heap or min heap. Max heap or min heap. Write the first one, max heap. Amma, any doubt? No? Oh. I don't know, break available or not? Lunch break available na? Oh, already exhausting, huh? I think Spock available in this. I don't know. Who's that? Who's the representative here? Devyani or any other? Any break? Can I give any break? Yes, take 5 minutes break only. Take only 5 minutes short break because I think everyone knows I need to take one small break. Just refresh and come back within 5 minutes. Make it fast. Come back within 5 minutes. All of you just come back within 5 minutes. Just don't waste the time in outside. Come back within 5 minutes. Take only 5 minutes break and refresh. Come back within 5 minutes. minutes. Come back within 2 minutes. Okay. 2 minutes లో స్టార్ట్ చేస్తానమ్మా, వచ్చేసేయండి. అలా if you come to the seminar hall and sit in your places, I'll start within 2 minutes. Open the pen drive. ఓకే ఎనఫ్, నేను చూసుకుంటాను. Must settle on fast. You already asked for 5 to 10 minutes break. Now that's the reason I already given for refreshments. Here I'm showing. I already told now. I awarded my PhD degree in the month of February. Yes, I awarded my Doctor of Philosophy in the month of February 14th, 2025. Recently, in this month, August 19th, I received Doctor of Philosophy PhD doctorate degree from the governor. I'll show those pictures. And in many of the news channels are live, TV9, V6, ETV Telangana. I don't know how many number of those papers are available. In those, all those papers available on 20th or 21st. I'll show those pictures. I don't know how this much of papers are available. I don't know. Uh, Now here, Vice Chancellor, Governor Bishnudev Verma, Telangana Governor, ISRO Chairman here, V. Narayanan, ISRO, our Indian Space Research Organization Chairman, like Abdul Kalam. Okay, Abdul Kalam, I think ISRO Chairman, not the previous ISRO Chairman. ISRO Chairman V. Narayanan, Governor and Vice Chancellor. This is Usmania Vice Chancellor. I received on 19th, and in many papers I don't know my name available. One more paper I don't know this one, and one more other paper I don't know. Karimnagar Vasiki Doctor. Hey, I'm from Karimnagar now. I received a call from media after 19th from all the channels that collected the complete details from my side and given the complete details of my parent details, including my children names also. Uh, my sister name Sunita and my kids name Sahasra, Dhruvika, and my wife name Usharani, and my mother name Bhagyalakshmi. Father expired in 2020. Name also available, Janardhan and Bhagyalakshmi's son. Okay. An English paper in Deccan Chronicle. Very big information also gathered. I don't know. 1, 2, 3, 4 paragraphs are written for about me. I don't know. And this is one the Sakshi paper available on 20 and 21st. And one more paper. I don't know these much of papers are available or not. So in all those papers, myself available on 20th and 21st in 2 days. Now, on 19th in Usmania University, Tagore Auditorium. And now in TV9. In TV9. In ETV Telangana. In ETV Telangana also available. Where is that? This is only the last one. So here, Governor, my certificate I received in ISRO chairman in front of. After few minutes, Governor left after giving that award, and for all the people given the vice chancellor only. I'm only the fortunate person to receive the doctorate degree in front of governor and ISRO chairman. Okay, and thank you for all those. And many print medias are also available. I given only from those. Makuddiya volume. Okay, enough. The C, I think you already written two types of heaps now. Padgodam. This first one, right? Max heap. I'll give the definition, and next after lunch I'll go for max heap and the mini heap with insertion and deletion along with the graphs. Okay, only few minutes left. Here I'm giving the 15 to 20 minutes class session before lunch break. Now just write here max heap. Write the very important statement in max heap. For every node small I, right here, for every node small I, for every node small I, comma, for every node I, stop talking, settle down fast. I think everyone waiting for lunch. Okay, something happening in your stomach. I think I knows. Within few minutes. Okay, waiting. I think a little bit big complex to wait up to 15 more minutes. Okay, but just wait up to 10 minutes. No problem. Just here I'm giving only the definition. Then I'll go for the construction of your max heap and min heap insertion and deletion after lunch. Okay, just write the definition of max heap and min heap. Max heap right here. For every node I, the value of node is less than, the value of node is less than or equal to its parent value. Matladadama. Stop talking. I'll repeat the same statement twice or thrice, but just don't discuss with zero volume. All the valid discussions are accepted, but just don't discuss with all the reels and so on. Okay. For every node I, the value of node is less than or equal to its parent value. For every node I, the value of node is less than or equal to its parent value. Right here like this. Right here like this. A of parent of I, A of parent of I is greater than or equals to A of I. A of parent of I, close the square bracket, is greater than or equals to A of I. Right, all of you, min heap definition. Reverse for this. Reverse for this. Min heap, write the side heading. All of you write the min heap side heading. All of you write the min heap side heading. All of you write the min heap side heading. For every node I, the value of node is greater than or equal to its parent value. Greater than or equal to అంటున్నాడు ఏంటి? ఇప్పటి వరకు గ్రేటర్ దాన్ కానీ లెస్ దాన్ కానీ వచ్చింది. ఇక్కడ ఈక్వల్ టు అంటున్నాడు ఏంటమ్మా? Till now, any same node available in binary search tree, any same value once again repeated in binary search tree, in AVL tree, in B tree, no, but duplicates are allowed in heap tree. Okay, the new case, new feature of heap tree here, duplicates are allowed. Same value available more than once also in any combination, in any place, in any level in your heap tree. Okay, how means I'll show in the next. For every node I, the value of node is greater than or equal to its parent value. ఒక్కటే చేంజ్ ఉంటుందమ్మా. ఇక్కడ ఏం చేంజ్ ఉంటుంది? రాయండి, లెస్ దాన్ రాయండి. లెస్ దాన్ ఇదా? Node, except for root node. For max heap and min heap, this condition is except for root node. Always just remember here, you are writing one condition, I parent of I is greater than or less than in max heap and min heap. This condition is exclusively for all the nodes available after parent node, not for parent node, not for root node. Okay. So how the max heap and min heap looks like, I'll show. Then I'll close this. Then after class, after lunch break, I'll go for the insertion of max heap and the discussion about max heap and complete the reverse for that max heap that is equal to min heap. Okay, I'll show after. First 70, then 50, then 40, then 45, 35, 39, 16, 10, 9. 70, 50, 40, 45, 35, 39, 16, 10 and 9. Now, this is equal to an example of max heap. How this example satisfies your condition, I don't know, but explain with an example very easy to understand. All of you draw this diagram. All of you draw this diagram. I'll give the definition. Okay. This is a complete binary tree. That is not binary search tree. Binary search tree is different. Binary tree is different. Binary tree contain maximum of 2 childrens. Binary search tree contain left side, right side values are different. Left side values are compared with root node, those are less than. Right side values are greater than compared with root node. Binary search tree is different. Binary tree is different. Okay. This heap tree is a CBT, not CBST. AVL tree is a binary search tree, updated version of binary search tree. Ante kadamma AVL tree. AVL tree is a updated version of binary search tree. And B tree also generalized version of binary search tree. But heap tree is not a binary search tree. It is a complete binary tree. I already given the definition of complete binary tree. Write the very important statement for this after tree. In max heap, I'll have you write this very important statement in box. I'll have you put this very important statement in box about max heap. In max heap, root node only, the largest element among all these. In max heap or in max heap tree, in max heap, root node only the largest element among all the values, among all those, or among all these, okay, among all these are all those, all the values your choice. Means 70 is compared with all the other nodes belongs to the largest element. Left side aina, right side aina, greater than element undadu. In the next level, root node or parent node in max heap belongs to the largest element. But binary search tree lo right side untadi kadama. But this is not binary search tree. This is B tree. This is B tree. This is binary tree. Which binary tree? Complete binary tree. Okay. Now reverse for this. Reverse cheyandi, min heap vachestadi. Parent node is equal to the largest value kada, compared to all. Parent node belongs to the smallest value among all those values in the next level. That is equal to min heap. That's it. But just don't write. I'll go for this tree and next. Okay. First, how to starts with index. Any array starts with the index value 0, na? But heap trees, the index value starts from 1. Right, like this: 2, 3, 4, 5, 6, 7, 8, and 9. So how to fill this? A, how many total? 1 to 9, na? So 1, 2, 3, 4, 5, 6, 7, 8, and 9. 9 numbers now in this tree. In this tree, 9 numbers. Tell me, AF1, 70. AF2, 50. AF3, AF3, 40. AF4, 45. AF5, 35. AF6, 39. Right. AF7, 16. 1, 6. AF8, 10. And the last element, Draw this. Index value starts from, this is index value, I node. Just write here the very important statement. In heap tree, index value starts from 1, from parent node. In heap tree, index value starts from 1, from parent node to the next level up to the last node available in the leftmost. Now, if I equal to 3, if I equal to 3, if I equal to 3, that condition satisfies or not will verify. That condition satisfies or not will verify. What that condition in max heap? A of parent of I is greater than or less than, I don't know. Greater than max ante gurtunchukondi, greater than, min ante less than. Greater than or equal to A of I. Now, how to calculate this? A of parent of I. Parent of I అంటే ఏంటమ్మా? I వాల్యూ ఏంటి? I వాల్యూ ఏంటి? పేరెంట్ ఆఫ్ 3. పేరెంట్ ఆఫ్ 3 అంటే 40 is parent. Parent of I. That is 70. 70 is greater than or equals to A of I. A of I means what? Satisfies. This one satisfies. Yes, compulsory condition satisfy kavalsinde in every case. If it didn't satisfy this condition, then it is not a max heap tree. I think how we are calculated. Any confusion? No, no. Parent of 40. Parent of 16 greater than. Yes, correct. 40 is greater than 16 here, correct? I equal to 7. I equal to 7 అనుకుందాం. 16th parent ఏంటి? 40 is greater than 16. Yes, correct. So you are satisfied. If you are not satisfied, mean that is not a max heap tree. That is not a valid max heap tree. But దానికి రివర్స్ ఏంటి? Min heap. Okay, reverse ఏంటి? Min heap. Creation, deletion, I will give after lunch. Take a lunch break, come back, shop after 60 minutes.